Obviously there are more in here which you can play around with, such as the power. So this basically will take a value for A, which we'll say is 10, and put it to the power of B, which we'll say, or is 9. A is 9 actually, and we'll say 9 to the power of B, which we'll say is 10. So it'll be 9 times 9 times 9 times 9, obviously 9 to the power of 10. It's going to give us a result of something like, I don't know, a gazillion. We'll see. I'm not really sure. It's going to be high though. See, we got 3.48 times 10 to the 9th. So that's a pretty huge number, but we'll go and reduce this and say 1 to the second power to give you an easier idea. It should just be 1, because 1 times 1 is 1. Yeah, there you go. So there's the power operator. And again, I would encourage you just to go in here and basically just kind of mess around with these components and see what they do. You know, I really haven't done a whole lot with them, but if you want to, actually, I'm going to go ahead and go into these equal, similarity, larger than, smaller than real quick, because I think that's kind of cool too. If I go ahead and grab a equality button, basically you've got an A and a B input, which is the two values that you want to analyze for equality. So I want to see if this number is equal to this number, which obviously it isn't, so it should give us a not equals sign. So basically what happens is it gives us a Boolean results, this equals does. And let me get another panel just to kind of put it in a better visual for you. We've got true. So I'm not going to go into too far on what you can do with a true value after you've analyzed something, but later on it's basically called a conditional statement. If something is true, then you can pass values or use it to define something further, which that's going to be for some later tutorials because it gets a little bit more advanced and you need to be able to understand some other things first. But just know that this value of true can be used to define other things in Grasshopper. Obviously, if I plug the equals sign in, this output will be false because the 2, 3, and -1 are not equal. So the not equal sign down here produces a true output, and this equal sign is going to produce a false because it is false. So basically telling you that. And it's the same thing with similarity. I think you can basically down here define how basically the threshold or how far apart they have to be considered similar. So it says percentage of A that B is allowed to deviate before inequality is assumed. So you can basically define the percentage here, and it's already defined as 1. So if I plug in, let's say 3 and 2, well, we're going to go ahead and and I'm going to introduce something else just to make this a little bit easier. We've got a 3 right here that I'm going to plug in the A, and I'm going to go to parameters, and I'm going to grab a number, which is right here. And this is basically something that you can just set a number to. You don't have to use a slider. You don't have to use some other type of data. You can simply grab a number parameter, right click on it, and click set number. You can also set multiple numbers into this thing, but I'm only going to set one. So I'm just going to say it's 2.95. Commit changes. And that should be within a 1% deviation of 3, and it should cause these things to be similar. So if I plug that in here and plug the panel into it, oh, I guess it's not close enough. So why don't we go ahead and set number at 2.99 and see if that's similar. True. See, okay, so 2.99 is close enough to be similar by our 1% deviation to allow a true in this equals output. So, I mean, that kind of gives you an idea. Let's see what this is. The absolute difference between A and B. So that just basically tells us the exact difference between the two, and I can plug that in and it'll say 0.01. I honestly haven't even used these before, but I think they could be valuable in some cases, and I think it's good to be able to understand. I think it's good for a further understanding of how components work and how you can just figure out components on the fly simply by hovering over them, seeing what they do, seeing what kind of inputs they are looking for and what kind of outputs they provide. So, I mean, Grasshopper is a very great program to just explore, and you'll learn new things every day just by exploring yourself. And please bring ideas to meetings if you would like. You know, we're always looking for new things. But I think this tutorial is about long enough for mathematical operators, so I'm going to go ahead and cut it off now. But I think the most important thing to have taken away is just kind of how data is being shown in these panels, and also kind of the number operator and things like that. So just be aware that data is extremely important, and the more you know about data in Grasshopper, and we'll go over more in these tutorials, the more you know about data, the better off you'll be. So with that, I'm just going to go ahead and end this, and thanks for watching.